Go over running the IPython notebook. And again, I'm going to do that by launching it from a terminal window where I've changed directory to where the code I'm interested in is, and I launch it by running IPython followed by notebook. Now this brings up this home page, and this shows me various IPython notebooks that I've already defined in this directory. I have the option of making new ones, but I'm just going to open this one that I've already created, IPython notebook. Now IPython notebooks are a combination of text cells and code cells and output cells. And to really kind of make full use of these, it's advantageous to learn the Markdown language that the notebook uses, which is Markdown. Although in this case, I have this is a heading cell, and I could have used a Markdown cell, and this is just for convenience for later typesetting and converting it to a PDF file. So a detail you don't need to be concerned about. But I can evaluate each cell by hitting the run, and there's actually I can run all the cells below, I can run all the cells above, etc. And here's just some code for the notebook that we don't need to be concerned about at this moment. But just by contrast between running the notebook and the notebook shell. So earlier we went over running Python through the shell, and that's done using the terminal in a Mac or the command tool in Windows. And as we showed, Python comes with its own default shell, but there are improvements, and this is just kind of demonstrated in the notebook. I can use IPython code to display an image, and here's just an image of me displaying about to execute the Python function in my terminal. And also this is just an example of a Markdown cell where I'm using HTML to make reference to a video, and I can evaluate that. And if I click on this, it's going to open a new window that's going to take me to the YouTube video. Okay, there are other third-party shells. The one that I use the most and that we're going to use in the class is IPython. But if you look at the Python web page, there is a wiki about Python shells, and there are other shells that you might be interested in exploring. Now, I think that IPython is a great environment for learning and exploring how to use Python because it has a lot of built-in tools to help you in that process. It has tools for helping us run the debugger, interacting with the operating system. It makes for easy integration with common plotting tools. It has a history that you can keep track of what you did. You can record what you did with logging, etc. You can also just run scripts directly from IPython, and we'll be demonstrating this throughout the semester. If you want to see all the ways that you can invoke Python, you can type the command IPython --help in your shell. One of the nice conveniences of IPython Notebook is it allows you to run system commands in the notebook itself by preceding commands with the exclamation point. And that will be demonstrated further. Here's a video with the IPython shell. Okay, so getting down here to the notebook, it's a web-based environment. It's all based on HTML5, CSS3, and JavaScript. And if you are already familiar with tools like JavaScript and CSS3, you can really do a lot of customization to the look and feel and how the notebook runs. So, like I said, we have text cells and we have code cells. This cell right here, if I click on it, see it brings up this is the original text in Markdown, and so I can use these pound symbols to denote different levels of headings. So right now it's a level 1 heading. If I change to a level 2 heading and evaluate the cell, we get a slightly smaller header, so forth. Lets me put links in. So here you see a link has the name of the link that I want to display in square brackets, followed by the location of the link in parentheses. And I can do bulleted lists with various levels of indentation. So that's an example of a markdown cell. Here's a code cell where I've put a simple Python statement. In this case, I'm calling the print function, and I'm telling it to print out. This is an IPython notebook cell. I'm executing the print function. So then when I run this cell, you see here's the output for it. And just as a note, in Python 2.7, print can either be a function, as I used it above, where I have print parentheses what I want the arguments for the function, in this case the string hello class, or as a statement, print followed by the string I want to print. The IPython has a number of dependencies that we don't need to worry about because we're using the Anaconda notebook, and this all comes installed with it. What really makes the notebook nice is in addition to the mixture of text, output, and code, which makes for what Donald Knuth from Stanford would call an example of literate programming, is the notebook can actually used quite generally. In fact, while it was originally developed as the IPython notebook, it has now been forked off and called Jupyter because it's kind of a general purpose environment where you have a web page interacting with some programming kernel. And so it was developed with Python, but it can be used with R, it can be used with Julia, Haskell, OCaml, etc. There's a variety of Ruby. There's a variety of programming languages that can be run directly through this notebook interface. Notebooks can be converted from the .ipynb note format to a Python format. It can also be converted to HTML, PDF, Word files, restructured text files, etc. So it makes it easy to share and put the code with other people. Like I said previously, the exclamation symbol allows you to execute system commands in the notebook, and I use this a lot. Those of you that aren't familiar with your shells, either a command tool in Windows or the terminal in a Mac, it's helpful to become familiar, look up and see the different kinds of things that you can do in it. So in a Unix environment, which is like a Mac is, I can ask who am I? Tells me I'm Brian. I can list the contents of the directory that I'm in. You see my notebooks, you can see some other code in there. I can list it with more details, telling me when it was created, what the permissions on the file were, etc. I can get what directory I'm in. I can change directory to another directory. And then if I do so that I went up a directory, now you see, I didn't do what I thought I would do, but anyway, so get to know what you can do in your respective shell, and it is oftentimes convenient for you to be able to interact with the shell through the notebook. The notebook comes with a number of what are called line and cell magics, and here's a link to actually an online HTML version of a notebook where people have demonstrated the different kind of magics functions you can do. So if you have a single % symbol, that denotes a line magic, meaning that everything that follows in that line will be fed to that particular magic function. If I have 2% symbols, that denotes a cell magic, which means everything in the cell will be fed to the magic function. So here's just some examples, and one of the things I use is time it, and this will run the code multiple times and give you an average of how long it took your computer to run it. And so here we're just going to create an array with NumPy, which we'll talk about in about a week. And we're going to create, if I remember right, this is 1 million element array, and I'm going to see how long it takes to create it and set every element in that array to 0. So it did it 100 times, and the best 3 performances averaged 1.7 milliseconds per execution time. Now I'm going to do the same thing, but I'm going to use the empty command, which just doesn't initialize the values. It leaves them all as whatever the random values in memory were. I run this again. This time it did it 1,000 loops, and the 3 best had an average score of time of 545 microseconds. So this is approximately 3 times faster than zeroing out all the values. There's a Ruby magic. There's also a Perl magic. And this allows me to execute Ruby code directly in the cell. Since Keith brought up the use of Cython last class, to show that there are Cython magics, so I'm going to import that, and now this is an example of some Cython code, which the details we don't need to worry about. Essentially, it's trying to make Python more C-like in terms of telling what all the variables, what kinds of variables everything is, etc. So I compile that, and this is a finance computation, and I give it some parameters. The parameters are described up here. This is called a docstring for a function. We'll pick up on that. But again, I can time. How long does it take to execute this Cython code? So it ran it a whole bunch of times, and the best performances averaged about 399 nanoseconds. Well, what if I do the same code, but I just write it in pure Python? I get similar values, but now let's time it with Python. And you see here we're getting 2.99 microseconds per loop as compared to 399. So using Cython is about 9 times faster than using the native Python. There's a bash magic. I don't think that there's an equivalent in Windows, although you can find documentation about how to write your own magic, and maybe this could be extended. But here I'm making a cell, and I'm going to execute multiple Unix commands, and it's all done there within the shell. Okay, let's make a first program. And this is a program that just really doesn't do anything, just kind of illustrates the different aspects of Python. And this is taken from the Learning Python book. So we have multiple lines here. And this is the code. I'm going to execute the code. And this is the output. So just some notes. So import system, I'm importing this module called sys that gives me information about the system that I'm running on. I do the print statement. I'm going to print the platform that I'm running on. In this case is Darwin, which is the underlying Unix for the Mac system. Then I'm doing some mathematics, etc. So let's kind of break this down. So what do we note? First off, the notebook is doing a nice job of color coding the different aspects of the code. So you can see like these reserved words in Python that have unique meaning, like import and print are typeset in a dark green. We have numeric constants that are in a light green. Mathematical operators here are in kind of a lavender. Oops. I created a variable called x. I've assigned it a string called spam. So a string is a sequence of characters. I'm doing a operation on that. Turns out to be string repetition. So I'm going to take the string spam exclamation point and repeat it 8 times. And this is what you see on the output. Just some notes about statements and expressions, kind of details that won't really matter to us, but just kind of putting it there for completeness. But again, to kind of highlight some of the important things that we're going to get up to that we haven't talked about. So like I said, we created a variable named x. So x is just a name, it's a location in the computer where I'm saving some value. And in this case, I'm saving the value span. We did some math. Here we did the numeric literal 2 raised to the power 100. And then we did some other things. Like I said, we did the string repetition by this x times 8. And you can see that symbols have different meanings based on the context in which they're placed. So in this case, this x times 8, when x is a string, means that it's string repetition. If I create a variable y equals 4, and now I do print y times 8, it's the asterisk now has a different meaning, which is multiplication. So that's an important thing that you'll run across, is different symbols have multiple meanings within Python. So that's just our first example of working with the notebook and creating some Python code, and we'll touch base on this, we'll examine this in much more detail in class.